Okay, today we are moving on to 3.4, and we are talking about choosing our own method. So all of the methods that we have learned this far, we are going to decide when it is best to use which method. So we know that we could solve this three ways. We could graph, we could eliminate, or we could substitute. If I were to graph, I would probably make these both in slope-intercept form, right? That would be my first step, would be to get y alone so that I could use slope-intercept and graph. If I were to use substitution, I would want to get one of the variables alone. Looking at it, it looks like this one would be the easiest to get y alone. So I would subtract 3x from both sides. And then finally, if I were to eliminate or use elimination, I would probably multiply that equation by 2 so that my y's would be opposite. Multiply the top one by 2. So those would be the first steps to using any of these. What do you think would be the easiest? I want you to think about what strategy would be best to use. So, looking at this problem, what strategy would I use to solve the system? Substitution or elimination? Substitution, right? It's very clear that I do have my y alone, so it's just going to be easier if I just substitute instead of having to move things around, multiply, get opposites, and eliminate. That might make things a little bit harder. So let's go ahead and use substitution. 3x minus y. So 3x minus 3 equals 3. So I take all of this, put it in right there. I have to put it in those parentheses so that I don't forget to distribute my negative, so that I have 3x minus 3x plus 3 equals 3. 3x minus 3 equals 0. So I'm left with 3 equals 3. Well, that's a true statement. So that's actually going to be an infinite solutions. So just like with any other equation, if you are left with a true statement, it's infinite solutions. If you're left with something that's not true, it's a no solution. Okay, and the next one, which method would you use to solve this system? I think that I would use elimination for sure because my x's are opposites, even my y's are opposites. So if I add, things are going to cancel out. So let's do that. Negative 6x plus 6x is 0. 4y plus negative 4y is also 0. So I get 0 is equal to negative 14 plus 10. Well, that leaves me with negative 4. And that's not true. So this one would be a no solution. Okay. Which method would you use to solve this system? I think, again, I would go here with elimination because I see that my x values are opposites. I've got one positive and one negative, and I think it's going to be easy to just multiply this top one by 3 so that I can cancel out my x's. So I would get positive 3x plus 9y equals negative 42. And now I can add, and my x values will cancel. So now I have 7y equals negative 28. And divide by 7 to get that y equals negative 4. And now I'm going to take that negative 4, and let's put it in our top equation so that we have x plus 3 times negative 4 equals negative 14. Add 12 to get that x equals negative 2. So we have negative 2, negative 4 for our final answer. So I think most of the time you're going to go with elimination. It's just going to make things a little bit easier when you don't have a variable by itself. Okay. Which method would I use here? Like I said in the last one, I think elimination is going to be our best bet. Neither of my variables are opposite, but I do see that I can make 8 into 16 just by multiplying it by 2, right? But instead of multiplying it by 2, I'm going to multiply it by negative 2. So that I have negative 16x, so that the x's will cancel. That makes positive 12y and positive 4. And now I'm going to just kind of cross it off so that I don't have to rewrite my top equation and I can just add. 16x plus negative 16x is 0. Negative 5y plus 12y is going to be 7y. And 17 plus 4 is going to be 21. So now I get that y equals 3. Which equation do we want to put it in? Let's put it in the top one. So we get 16x minus 5 times 3 equals 17. 16x minus 15 equals 17. 16x equals 32. X equals 2. Final answer, 2, 3. Okay, we have a challenge one. This one's going to take us a bit of some time. How could we solve this system of equations? Well, let's start off by multiplying this top equation by 2 so that we can get rid of these fractions. So this is going to become 4y is equal to 7x minus 11. Okay. My second equation does not match the x, the y's. They're not lined up. Nothing of the sort. So let's go ahead and move it so that we can get things lined up. So if I subtract my 6y, it's going to be on the same side as the 4y. It's on the other side of the equals. Then I have the 6x plus 66. Okay. Can't really cancel anything here, but my y's are opposites, so let's also make them have the same coefficient. If I multiply the top by 3, I can get 12y is equal to 21x minus 33. And then I'm going to multiply the bottom by 2 so that I get negative 12y equals 12x. And then we'll have plus 132. Okay. So obviously now, when I do go through with adding, the y's are going to cancel. I have 0 over here. 21 plus 12 is going to give me 33x. And then I have negative 33 plus 132, which is going to give us 99. Okay, so following like how to solve equations, let's subtract 99. So we have 33x equals negative 99. If I divide by 33, I would get x equals negative 3. Look at that. We already solved for one variable. So lots of steps, but we did get it. So let's keep going. Let's use this equation right here to put our x in. I just want to use it because it's got the smallest numbers in it. So 4y equals 7x minus 11. So we're going to go ahead, rewrite this. 4y minus 7x, which is negative 3. So 4y equals negative 7x. Or I'm sorry, 7 times negative 3. minus 11. For y equals negative 21 minus 11. For y equals negative 32, y equals negative 8. Final answer, negative 3, negative 8. Okay, lots of steps, but we made it through all the way to the end, and we did get a final answer. So typically elimination is going to make things a lot easier for you. You really only are going to substitute when you do have a variable by itself, okay? So if you're going to substitute, you're looking for x equals or y equals in one equation, and you are substituting it into the other. If you don't have that, you should be able to isolate a variable in one step. Never use substitution if you're going to end up with fractions when you isolate your variable. So like if you, just like with our standard form, if I end up with a fraction, I don't want to use that. Elimination, you're looking for opposites. And if you don't have them, you are multiplying to make them.